para matar, AD. Right, so we get one equation for AD. Y is equal to minus 2x plus 11. Alright, keep them coming in, guys. We'll do these solutions as long as I get one answer that's different. I think the solution. EDY is equal to 2x. I'll assume there's a plus the line. 2x plus 11.
Yes, I forgot to click shift now.
Alright, so I'm gonna get y is 2x plus 11. Alright, so off the bat, right, fellas? I want a little analyze these two answers I get here, right? For A, D. One is minus 2x plus 11. The next one is 2x plus 11. Which one are you think looking correct? And I'll show you all how to deduce this in a little while. Right. So I've seen some different answers coming in. So let me fix them now. We'll do all the equations. Right. So we'll do all the equations, right? So am I write down all the points? A is minus 4, 5. B was 310. C is 6 minus 2. And D is minus 7 minus 3. So the first one you're going to do is AD.
Excuse me, sir.
Yeah.
And for A, that is minus 3.
For A, oh, minus 3. Okay, sorry, my
Yes,
bad.
minus 3 for A.
Cool. So AD. I'll write down A, I'll write down D. Minus 3, 5. And the D is minus 7 minus 3. So I'll call this my x1 and my y1. I'll call this my x2 and my y2. To get the equation, I need the gradient. So gradient of AD. Now, I'm going to start introducing a little more terminologies in the questions, all right? And I want you all to get familiar with them. Now, the gradient, there's a symbol for gradient, just like we have the symbol for the length of a line, which was the two straight lines. There's a symbol for gradient. Gradient is symbolized by common M. All right, that's the symbol for gradient, common M. Now, what I like to do, since this is the gradient of AD, there will be questions where we will have to calculate the gradient of more than one line. So I like to specify which gradient I'm talking about by putting the name of the line as a subscript. So M subscript AD will be the gradient of AD. All right, that's just the symbol we will use. Write down the formula, y2 minus y1 over x2 minus x1. You all heard me properly, right? Y2 is minus 3, take away y1 is 5. Over x2 is minus 7, take away x1 is minus 3. minus 3 minus 5 is minus 8. Minus 7 plus 3 becomes minus 4. Yeah? Which is equal to 2. Right? So those of you all who got the gradient wrong, you all see your mistakes. Yeah? Next, equation of AD. And I will use A. I'll use the point A. If you wanted to use the point D, you could have big up yourself and use the point D. And it's given by the equation y minus y1 is m into x minus x1. So y minus x1, y1, y minus y1 is m into x minus, and x1 is minus 3. So y is equal to 2x. This becomes plus in the brackets. So 2x multiplied by 2 by 3 is 6. The 5 goes across, becomes plus 5. And I get the formula, y is 2x plus 11. Yeah? You'll see that. You'll see the mistakes. Once we weed out the mistakes, that's all I concern about. Weed out the mistakes and fix them. Next, we will do what next did you all give me? BD. Let's do B, where B is 310 and D is minus 7 minus 3. X1, Y1, X2, Y2. Again, the gradient of BD symbolized as M subscript BD is equal to, I'll write the formula again. The reason I want to write the formula again is because I want to remember the formula. The best way to remember something is to just keep writing it over and over and over again. Y2, take away Y1, over X2, take away X1. Minus 3 minus 10 is minus 13, minus 7 minus 3 is minus 10. A minus and a minus is a plus. 13 over 10 is my gradient. Equation of BD, and I'll be using B, which is 310. X1, Y. Now you could have used D as well if you wanted to. Nothing is wrong with that. Cool? Equation of BD is y minus y1 is m into x minus x. Y minus 10 is 13 over 10 into x minus 3. Y is equal to 13 over 10 minus, now if you're uncomfortable, go to your calculator. 13 over 10 multiplied by 3. Change it to improper fraction, 39 over 10. So that is minus 39 over 10. And move the 10 across, it becomes plus 10. And again, go in your calculator. 13 over 10x minus 39 over 10 plus 10. 61. Yeah? Now, the reason I want it in this particular form, and if you had it in another form, it's no problem. The reason I want it in this form is the equation is because the equation of a line, I can look at the equation of a line and pull out certain information from it. And the only time I can pull out information from it is if it looks like this. Y is equal to something by X plus something. That the only way I could look at the equation and grab information out of it. All right, so we did these two. I'll leave the last one for those who got it wrong to fix it. All right, if you probably made a mistake in the last one, you have the time to double check it after class. All right, do that as a piece of your home lesson. To fix the last one, which would have been BC. All right. So today we're going to continue talking about the equation of a line. I'll continue the notes in the same document. So we'll continue talking about the equation of a line, and more specifically, how it's supposed to look. We just now established that the gradient, 8th of August. We now established that the gradient of a line is symbolized as common M. The length of a line or the length of, let me say, for example, AB is symbolized as a line AB and a line. We learn about the midpoint of a line. Is symbolized capital M. And the equation of a line, which I will say is the most important one. The equation of a line is, I'll say symbolized, for lack of a better term, as y is equal to mx plus c, where m will represent the gradient and c will represent the y-intercept. Now, what is the y-intercept? This is where the line cuts the y-axis. So let's see what that means. Let me make up our equation now. Y is equal to 5x plus, let's say, 11. All right. Y is equal to 5x plus 11. So look at the equation. Look at the equation here. Does it look exactly like this? Y is mx plus c. Yeah. So when our equation is looking like this, I can watch it, pull out what the gradient is, and pull out what the y-intercept is. What is the gradient of this line?
5.
5. Very good. Now, some of you all might say it's 5x. Remember, the gradient is a number. The gradient is the number in front of x. All right? The number in front of x is 5. What is the y-intercept?
11.
11. So I can check it on GeoGebra. I can actually pull the tools to calculate the gradient. The gradient is indeed 5. And the y-intercept is indeed 11. You see where it cuts the y-axis here? All right, let's make up our next one. Y is equal to minus 2x plus 6. What will be the gradient of this line?
-2.
-2.
Good. What will be the y-intercept?
6.
6.
6.
So if I hit the function The gradient is indeed -2. And the y-intercept is indeed 6. Yeah? All right, let's do our next one. Y is equal to x plus 2. What's going to be the gradient of this line?
1.
1. All numbers, let's say for example, 2. All numbers are multiplied by 1, divided by 1, and raised to the power of 1. But we do writing them things because it's generally accepted. 2 is 2. It's still 2. It's still 2. It's still 2. Agreed? But we do writing them extra things there because it's understood. Same thing for a variable. X is multiplied by 1, divided by 1, and raised to the power of 1 as well. It doesn't matter where this multiplied by 1 goes, I could have it here. 1 by x is 1x. X is the same thing as 1x. It's the same as 1x to the 1. It's the same as 1x to the power 1 divided by 1. All of these is x. But we don't write in the power, we don't write in the denominator, and we don't write in the number in front of it because it's understood to be there. So what's the number in front of x for this particular equation? For this one here.
1.
1. So the gradient is 1, and what's the y-intercept?
2.
2. Let's check and see. Gradient is 1, and the y-intercept is indeed 2. Yeah? And that is the reason I wanted you all to write all of these equations like this. So let me go back up. All right. What is the gradient of this line?
Two.
Say that again.
2.
May I hear it, Tyrese?
2.
2. And what's the y-intercept?
2.
2. What's the gradient of this line?
-1.
And what's the y-intercept?
-1.
Very good. What's the gradient of this line?
-7/9.
And what's the y-intercept?
8/3.
8/3.
What about this one? Gradient and y-intercept.
2 and 11.
This one.
Oh. There's a 12 or 13.
13.
13/10. And 61/10.
Very good. So this is where the challenge comes into play. I'm going to write the next equation here. 2y is equal to 10x minus 6. What's the gradient of this line?
5.
And what's the y-intercept?
-3.
Very good. Explain why.
Because is 2y and 2y is that you have to make it thing for the equationary line, yeah. You have to make it for the equationary line for one
Which
y.
is
Which is y is equal to 10x minus 6 over 2.
very good. Very, very, very good. Easy misconception here. Students will just say, well, you know, number in front of x represents the gradient, which is correct. But the number in front of y is supposed to be 1. Over here, the number in front of y is not 1. Number in front of y is 2. All right. So in a case like this, if I would draw the gradient, you see the gradient here is 5. But over here, the number in front of x is 10. The y-intercept supposed to be -6, but the y-intercept here is -3. Yeah? This is where you have to be comfortable doing your working, making y the subject of the formula. So let me do some examples on the equation and shifting things around in an equation. So 2y is equal to 10x minus 6. If I divide everything by 2, remember, whatever I do on the left, I will do on everything, every single thing. And we did this in solving equations, correct? If I divide by 2, 2y over 2, and this time I'll divide everything by 2. Bam, 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 bam. 5, 3. I get y is equal to 5x minus 3. Now, there's a statement I would like you all to learn to write at the end of every single equation you calculate. Is of the form y is equal to mx plus c, where m is the gradient, which is equal to 5. And c is the y-intercept, which is equal to -3 in this case. Yeah? You're comfortable with that? All right, let me do our next one now. 4y is equal to 3x minus 12. Tell me what is the gradient and tell me what is the y-intercept. First of all, what are we going to divide by?
4.
4. So I'll divide everything by 4. I get 4y over 4 is 3 over 4x minus 12 over 4. You cancel out with you. Nothing could cancel for my x term. And you cancel with you and I get 3. So I get y is equal to 3 over 4x. Take away 3. Agreed? Write down your statement. Is of the form y is equal to mx plus c. So if you realize, I lining up my generalized form with my equation I have, so I could see clearly what m is, I could see clearly what c is. Where m represents the gradient, which is equal to, in this case, 3/4, and c represents the y-intercept, which will represent -3. Yeah? Let me tackle our next one now. Let me kind of mix it up a little bit now. Again, this will follow solving equations. So I'm solving for y every single time. So my first step, bring everything in y on the left, send everything else on the right, simplify both sides, divide by the coefficient of y every single time. Six x plus 7y is equal to 3. Bring everything with y on the left. I already have everything with y on the left. Send everything else on the next side. But when I send it on the next side, I want to put my x's first. So I'll be smart. I'll have 7y is equal to minus 6x plus 3. Everybody comfortable with that movement? Then I'll divide by what? What am I dividing by?
7.
7. Very good. I get 7y over 7 is minus 6 over 7x plus 3 over 7. Nothing could simplify except the first one. The 7 cancels. And I get y is equal to minus 6 over 7x plus 3 over 7. And you write your statement is of the form y is mx plus c, where m is the gradient, which in this case is negative 6 over 7, and c is the y-intercept, and in this case it is 3 over 7. You all think you all get the hang of that? All right, I'm gonna put 3. Try the 3 for me. All I want is the gradient and the y-intercept. 2x is equal to 4 minus 7y. 3 is equal to 2x plus 4y. And the last one, 6x plus 4 minus y is equal to 0. Try those 3 for me. Right, as quickly as you can. Give me the gradient, give me the y-intercept. All right, so the first one, I have to move the 7y minus 7y across, move the 2x across. That are the only 2 things that I need to move in this case. So when I move the minus 7y, it becomes 7y is equal to minus 2x, and that plus 4 remains there. All right, give me a second, fellas. All right, cool. Then I'll divide by 7. And I'll get 7y over 7 is minus 2x over 7 plus 4 over 7. U cancels with u. Y is equal to minus 2 over 7x plus 4 over 7. Yeah? Now you might see a little difference between this line here and these lines are writing up here. I just write it a little different, right? It doesn't mean any different. I just write it a little different. All right, hold on there. Yeah, fellas. Sorry about that. All right. Number 1. Talk to me. Any problems with number 1? All right. Remember, is of the form. Very, very important statement, huh? Very, very, very important statement. Where m will represent the gradient, which is minus 2 over 7. And c represents the y-intercept. which is equal to 4 over 7. All right, now this one, I'm gonna show you a little trick here, right? I'll do the harder way first, and I'll show you all the easy way. Move the 4y, move the 3. Minus 4y is 2x minus 3. Yeah? Divide by minus 4. Minus 4y over minus 4 is 2 over minus 4x minus 3 over minus 4. This cancel with this. This is a negative because a plus and a minus is a minus. I get minus 1 over 2x. It doesn't matter where the negative sign goes. If you put it on the numerator, is no problem. If you put it on the denominator, is no problem. If you put it in front of the whole number, no problem at all. Over here, minus and a minus is a plus. So we get plus 3 over 4. That's the hard way to do it. The easier way to do this question, and I'm giving myself a little bit of space here. I'm giving myself a little bit of space. The easier way to do this question is, you see, in all of the questions we did, the coefficient of y was positive. All right. If you didn't notice that, then we go back up. The coefficient of y here was positive. 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 1. 1. Gotta go all the way up when we solve the equations. Right? The coefficient of the variable we're solving for was positive. This one was negative, no problem. This one was negative, no problem, because we didn't separate them. Down here, for all of these equations, we dealt with positive coefficients of y until we reach this one, which is a negative coefficient of y. I might as well leave y positive because it's easy to work with it. So we can have a little bit of versatility when we rearrange it. Instead of putting the 4y across and the 3 across, I'm just going to move the 2x. 3 minus 2x is equal to 4y. This line here and this line here have the same value. I just write it a little different. If I tell all you, well, you know, fellas, 10 is equal to 49. And then I come and say 49 is equal to 10. Does this line and this line mean the same thing? It indeed does. So if I come and tell all you, fellas, x is equal to y plus 3. And then I say, fellas, y plus 3 is equal to x. And these two things mean the same thing. Transition that up here. Instead of saying 3 minus 2x is 4y, I can say 4y is 3 minus 2x. Yeah? It's the same thing. If I want, I could send the 3 on the next side here. The 3 here jumping no equal sign. The 3 not jumping no equal sign. 4y is minus 2x plus 3. Yeah? Only when that 3 jumps at equal sign, the sign in front of it will change. I'll just divide by 4 now. 4y over 4 is minus 2 over 4x plus 3 over 4. Bam, bam. Y is equal to minus a half x plus 3/4. I get the exact same answer using a little different method. The only reason I'll probably use the orange method is if I am not as confident working with negative numbers. All right. If you're not confident working with negative numbers, just move the y on whichever side to make it positive. So if I do the exact same thing here in this last example, I can say 6x plus 4 is equal to y. When I move the y across, I end up with plus y. The 0 has no value, so I could omit the 0. I could leave it out. Yeah? In the same way I say if one side is the next side, the reverse is the same. Y is equal to 6x plus 4 is of the form. Right, you'll have to write it for the second one as well, right? Y is mx plus c, where m is the gradient, which is 6, and c is the y-intercept, which is equal to. Well, you're comfortable with that? Everybody good with that so far? Yeah? Perfect. So, the reason I'm doing this is because sometimes a question is going to ask you all to calculate the equation of a line using information from another equation. And I have to make the equation look a particular way to pull out information from it. So my aim is to pull out information from an equation. Now, we talk about calculating the equation of any line in coordinate geometry. So asking a question, if you all could remember, what do we need to calculate the equation of a line? What do we need?
You need y1, the gradient, and x1.
All right, y1, the gradient, and x1. All right, you could just use the formula to see what you need, correct? And that's why I do Dylan. To summarize what Dylan said, I need the gradient. I have to have the gradient of the line, of that line, correct? And I need a point on that line. It could be any point on the line. Remember, we did the exercise where everybody picked their own point and calculated the gradient, the equation, and everybody would have gotten the same equation at the end of the day. All right, that goes to show you can use any point on the line. We need to talk about two more types of lines. One line is parallel lines. Right, easy peasy. Parallel lines have the same gradient. Yeah, they have the same gradient. The next one, most important thing in coordinate geometry, is perpendicular lines. This question comes every single year in coordinate geometry, every year. Perpendicular lines. Now, for parallel and perpendicular lines, we're talking about gradients. That's the most important feature with parallel and perpendicular lines in this topic, the gradients. So the gradient of parallel lines are the same. The gradient of perpendicular lines, we have a law that we need to use. So for perpendicular lines, the product of the gradients of perpendicular lines will be -1, which means if I have a line, let me draw some stuff here. If I have a line, let me say this is line AB. We calculate the gradient of, we get 2/3. Yeah. I will make it a whole number. Good. Now I will use probably 2. Right. So the gradient of AB is 2. Yeah. The law says that if I draw a perpendicular line to AB, let me say at 0.5 here. And let me say the name of this line is CD. All right. Now, if you watch, the word perpendicular means 90 degrees. Yeah. So the angle made between AB and CD, or the angle made between the two lines, is 90 degrees. Yeah. The law says, if I multiply the gradient of AB by the gradient of CD, I'm going to get -1. Let me transition that into some notes here. For example, using the same case I draw here, the gradient of AB is equal to 2. CD is perpendicular to AB. Therefore, M subscript AB, which is the gradient of AB, multiplied by M subscript CD, supposed to be what? When I multiply both gradients, what am I supposed to get? It right here on the screen.
-1.
-1. Yeah? Because homeboy here is the gradient of AB, homeboy here is the gradient of CD, and AB and CD are perpendicular. Yeah? So now, let me put in what information I have now. Brother man was 2 by the gradient of CD is -1. Yeah? Just like when we solve in equations, I'll divide by 2 on both sides to get rid of this 2 here. And the gradient of CD is -0.5. Now, this is the long way around calculating, right? And I'll show you all the easy way to calculate. So if I come back on GeoGebra and I figure out what the gradient of this line is, it is indeed -0.5. Yeah? So every single time, M4 by M5 is going to be equal to -1. If I do this, M4 by M5 is going to give me -1. Right? Now, this is approximations here, right? I'll try to get some better, nicer numbers. -1. I'll get -1 as well. This is 3/4. This is 3/4. And this is 4/3, -4/3. All right, you can check it. 3/4, 0.75 is 3/4. 3/4 multiplied by this here, this is -1 and a third, which is -4/3. Multiplied by -4/3. I get -1. I'm trying to get some nice numbers to work with. 1.375. There's an approximation here. 1.375 is what? 1.375 is 1.38. 1 3/8, or 11/8. All right. So this number here, M4 is 11 over 8. M5 will be 8 minus 8 over 11. Right? We could check it. 8 divided by 11 is 0.727 going down the root. All right? When I multiply them two numbers, I'm going to get -1. And that's the concept of perpendicular lines. When I multiply the gradient of two perpendicular lines, I'll get -1. But this working, it could be a little bit tedious, especially if you're struggling with your algebra a bit. But there's a workaround. There's an easier way to do it. If we have the gradient of a line of a, let's say the line is L1. All right? And L2 is perpendicular to L1. To get the gradient of L2, we put 1 over L1 with a minus sign in front of it. That's it. For example, down here, I have the gradient of AB. I want the gradient of CD. The gradient of CD is -1 over the gradient of AB. Easy? So let me draw a little table here. And I'll gonna cut notes. We will have gradients of line. Actually, this could be line, and it's gonna be perpendicular. All right. The table is a gradient table. And I'm gonna put some numbers. 4 minus 2. 3 over 7 minus 4 over 11. 12 over 5. I think that's good enough. And this is what we're doing. All we're doing is putting -1 over each of these numbers here. So for example, for the first one, if I have a line that has a gradient of 4, the gradient of a perpendicular line to that will not be -1 over 4. The gradient of a perpendicular line for the second one is going to be -1 over -2, which is 1 over 2. Are they getting drafted yet? Now, when it comes to fractions, this is what I want all to do. Flip the fraction and put a minus sign in front of it. That's all. So my working gonna be -1 over 3 over 7. Fellas, flip the fraction and put a minus sign in front of it. And that's the gradient of the perpendicular line. All right. Come on, good.
Yes, sir.
Good. So I'm gonna put some more for you all here and get the perpendicular line gradient for me. 7, 3, 11 over -11 over 12. 21, 40, and -1 and 3 over 10. I do this question for me here, and I'll come back. All the answers in the chat for me. Good. Perfect. Excellent job, everybody. The gradient is 3/2. Well, GeoGebra will give me it in decimal format, right? Do not work in decimal format for you guys. Cool? Nice. Calculate the midpoint of AB for me. Perfect. So the midpoint is 5, 4. Yeah? Next. So that is two pieces of working we did so far. The gradient of the line, the midpoint of the line. Easy? Next. Give me the gradient of the perpendicular line to AB. We just now do the table. That's how you're calculating the gradient of the perpendicular line. Tell me what again. Nice. When I'll finish calculating this gradient, this here, this here is going to be the perpendicular bisector, correct? And we have the gradient of this line. And we have a point on this line. Yeah? Calculate the equation of this line for me. We have the gradient and we have a point. That's all we need. Oh. One man give me answer there. Let me see if it's correct. I'm waiting for some more answers. Alright, let me try a thing then. So we established, sorry. Right, I'll just write down the numerical values here. Then I'll do a question showing all statements and looping, okay? You all told me that the gradient of AB was 3/2. You all told me the midpoint of AB was 5, 4. You all told me that the gradient of the line, this is the symbol for perpendicular. Perpendicular to AB was -2/3. Yeah? We have enough information to calculate the equation of the line perpendicular to AB using 5, 4. Because 5, 4 is the point on the line. Y minus Y1 is M into X minus X1. This is my X1, this is my Y1. Y minus Y1 is equal to M minus 2/3 into X minus 5. Y is equal to minus 2/3 X minus 2/3 by 5, minus 5, sorry, is plus 10/3. Minus 4 goes across to become plus 4. Fix it up, minus 2/3x plus 4 is 12/3, so this is 22/3. Is of the form y is equal to mx plus c, where m is the gradient, which is minus 2/3, and c is the y-intercept, which is equal to 22/3. So it's nothing new. It's nothing new. It's just a combination of all of the things we have been calculating from when we started learning coordinate geometry. Gradient, midpoint, gradient of perpendicular line. That's the three things that we need to calculate the gradient of the equation of a perpendicular bisector. Extremely easy. And the question comes every year. The question comes with variations, how they will ask it, but it's the same concept throughout. So let me go and put another one here for you guys. Same things we calculated, but this time I'm going to change the line. Right? A, calculate the equation of the perpendicular bisector. You're doing the same exact things we did just now. Right? I will put that on the side so you all will see it. And that is ABD. 2, 1, and 7, 7. Go ahead. Take your time and do it. No rush. That waiting for the answers in the chat, right, guys? Alright, I've seen a couple answers coming in already. Alright, I'll be chatting now, fellas. All I need a couple minutes again.
Almost done, sir.
Hey, big up, big up, big up. Alright, I'll just give you some guidance in the meantime. Make sure in the correct track. The gradient of AB looking like 2/3. The perpendicular gradient will be -3/2. And the midpoint looking like 5/2, 4. Yeah? So now we have a point that is a fraction. How are we going to deal with it? Right, continue looking. I will give you all a couple more minutes and I'll do the solutions. Right, looking correct, Dylan. Looking correct, Aidan. All right, so I'm gonna start doing the work, right? So while other viewing the recording, I'll let you take down all the notes, right? So this is for the second question. The gradient of AB, we got it to be 2/3. So the gradient of the line that is perpendicular to AB would have been -3/2. And the midpoint of AB would have been 5/2, 4. Equation of perpendicular line to AB using the point 5/2, 4, y minus y1 is m into x minus x1, m x1, m y. Y minus 4 is -3/2 into x minus 5/2. A fraction is a number. We deal with it the exact same way we would have dealt with a whole number. Y is equal to -3/2x. A minus and a minus is a plus. And then I multiply out the two fractions. I get 15/4 as my fraction. Move the 4 across, it becomes +4. Y is equal to -3/2x plus 15/4 plus 4 is, that is 16/4. 15 and 16 is 31. 31/4 is of the form, tralala, finish off your statement, and that's your answer. Good to go? Comfortable? A little more comfortable now with questions like this? All right, so this is what I'm going to do for you guys, right? You all will view the recording as soon as it's rendered. I'll put the recording, so you all will have to watch the video to get your homework. This is your homework. I'm going to put a series of lines here. I'll put in a line in each quadrant. Your job is to calculate the equation of all perpendicular bisectors on the lines, right? Right, ignore this. This is the length of the line here, right? So ignore this number. All these numbers here are the length of the line. So you can ignore that for now. Right, you have all your points. Then points looking a little too easy, man. Right. 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 Cool. I like that a little more. All right, so you're calculating the perpendicular bisector of each of these lines for me. Anybody have any questions? Everybody good? I still putting this in the notes, so I will remember So you have to go and watch the recording to get your homework and take down your notes, right, fellas? All right, so before we end class, this is our third class. I want to get some feedback from all. How are we going so far?
So I think it's going real good so far.
Now you're obligated to tell me the truth. All right. Everybody at least learning something so far. Dominic, you come an hour later. Class start 10:30.
Yes, sir.
Wake up early. Stop playing Apex so late in the night. Anybody have any questions? Any queries? Anything they want me to clear up with them? All right, so in the next class, we will be completely finished with this part of coordinate geometry when it comes to straight lines. So in the next class, we're going to do a worksheet compiling of a lot of questions, a lot of different ways they will ask questions, and we will be rooting out things that we know the concept of, but we don't know how to execute the working for. All right, the knowledge is there, but we have to know how to apply it. Right, so that's what we're doing in the next class, which will be Thursday. So be on time. If you all have no questions, you all can go ahead and leave. Look out in your emails for the link for the recording.